Go over there. As the American fleet approached the Strait of Hormuz to fully reopen it and restore the passage of oil tankers, the U.S. Navy faced a critical obstacle. Iranian forces had laid underwater mines across the strait, effectively blocking all maritime traffic. Clearing these mines would be one of the most dangerous phases of the entire operation, requiring precision, patience, and constant protection against Iranian air and missile attacks at the same time. Modern naval mines are not the simple floating contact devices of past wars. Today's mines sit on the seabed or are anchored at a set depth below the surface, invisible from the deck of a ship. They use a combination of sensors, magnetic, acoustic, and pressure to detect passing vessels. A magnetic sensor picks up the metal hull of a ship, distorting the Earth's magnetic field. An acoustic sensor listens for the specific sound signature of a vessel's engines and propellers. A pressure sensor detects the change in water pressure created by a large hull, displacing water as it passes overhead. Advanced mines use a combination of all three, requiring multiple conditions to be met before detonation. This means a mine can explode under a ship without the vessel ever physically touching it. While the underwater drones scanned the wider area, situations requiring precision work called for human divers. In their quarters below deck, Navy explosive ordnance disposal divers suited up. They pulled on their wetsuits, strapped on their breathing apparatus, checked their equipment, dive computers, underwater lights, communication gear, tools. Once ready, they climbed into rigid hull inflatable boats and motored away from the ship toward the coordinates flagged by the scanning teams. While the divers moved out to their dive site, the rest of the operation maintained full defensive posture. Soldiers on the ship stayed behind their machine guns, eyes on the sky and water. Lookouts with binoculars swept the horizon in continuous rotation. The threat of an Iranian drone or missile attack while the fleet was slow and occupied with mine clearance was constant and real. The fleet reduced speed to a minimum. At high speed, the risk of running over an undetected mine was too great. Every ship in the formation slowed to a crawl. All onboard sonar systems and mine detection scanners were active, sweeping the water ahead and below the hulls. The cruisers and submarines in the group were brought to full combat readiness. Anti-air systems were active, tracking the skies for Iranian Shahed drones and ballistic missiles that could be launched at the fleet while it was moving slowly and vulnerable in the narrow strait. Helicopters launched from the carrier and began flying patterns over the water ahead of the formation. Door gunners sat behind their weapons at full readiness, scanning both the horizon for enemy threats and the water surface below for any visible signs of mine activity. Some helicopters towed mine detection equipment. Sonar sleds dragged through the water on long cables that could identify objects on the seabed and relay the data back to the ship in real time. The helicopter crews worked sector by sector, methodically sweeping the route the fleet would take through the strait. The divers reached their location and entered the water. They descended along the coordinates provided by the sonar team. Visibility was limited. They moved slowly along the seabed using their lights, searching through the reef structure. They found the mine wedged deep in the coral, partially buried in a position where an unmanned vehicle could not safely maneuver to neutralize it. The divers conducted a close visual assessment, confirmed the type and condition of the mine, and reported back to the ship by underwater comms. The decision was made not to attempt manual disarming. The mine's position in the reef made it too risky to handle directly. Instead, the divers marked the location and ascended back to the surface. They swam clear of the area and returned to their inflatable boat, putting distance between themselves and the mine site. From the ship, the crew deployed a mine disposal vehicle, a small, remotely operated submersible designed specifically to approach and destroy mines underwater. The vehicle was lowered into the water and guided by an operator watching a live video feed on a monitor. The disposal vehicle descended to the mine's location, approached carefully, and placed a charge next to the device. The operator confirmed the charge was in position. The vehicle backed away to a safe distance. Throughout the entire process, everything was displayed on the computer screens in the operations room. Oh, sorry, that's the commanding officer, the EOD team leader, and the sonar operators all watch the same feed. The position of the mine, the disposal vehicle, the charge placement fully visible and fully controlled. The charge detonated. A muffled underwater explosion sent a column of water and debris to the surface. The mine was destroyed. The sonar team confirmed the contact was gone. The route was clear at that point. On the lower decks, ammunition handlers brought up crates of belted rounds for the deck-mounted heavy machine guns. The belts were unpacked, inspected, and carried topside. The ammunition was fed into the guns and locked in. The gunners charged their weapons and fired short test bursts over the water to confirm the guns were cycling and ready. These machine guns served a dual purpose. They could engage enemy drones in the air, and they could also be used to detonate floating mines spotted on the surface at a safe distance.